we're going to do is we're going to solve systems of equations by substitution and elimination. Our first three examples are going to be substitution. Now, when we're solving substitution, what we do is we see which variable is by itself, and in this case it's the y. So we take the expression that it's equal to and we plug it into the variable in the other equation. So since 2x minus 1 equals y, we replace the y in the other equation with the 2x minus 1. So what it looks like is x plus, but instead of putting a y, what we're going to do is we're going to put the 2x minus 1. Now we're going to add the like terms. So we have x and 2x, which is 3x. We're going to add the 1, and that gives us 9. Then when we divide it by 3, we get x is equal to 3. So once we get that, what we're going to do is we're going to take the 3 and we're going to plug it in the other equation. It doesn't matter which equation you pick. I'm going to pick the top one. And so when I plug it in, what I have is y equals 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. So y equals 5. So our answer is the ordered pair 3 and 5. Now, for our second one, what we're going to do is we're going to take our expression, x plus 4. Since that's equal to y, what we're going to do is we're going to plug it in for y in the other equation. So when we do that, what we get is 2x plus 3, but instead of putting a y, what we're going to do is we're going to put in the x plus 4. Now we're going to distribute the 3 to each of the terms. So what we have is 3x plus 12. And we add the like terms, and then we subtract the 12. And then when we divide it by 5, what we get is negative 1. So we're going to take that negative 1 right there, and we're going to plug it into one of the equations. I like the top one. So that gives me y equals negative 1 plus 4. Negative 1 plus 4 is 3. So that means that my answer is negative 1 and 3. Now, for our last one, this one's slightly different because if we look at it, notice that it's not y equals. In this case, it's x equals. So that means we're taking the expression 2y minus 3 and we're replacing it with the x. So what that gives us is a 2. And then we have the minus 4y equals 5. We're going to replace the x with the 2y minus 3. And what we're going to do is we're going to distribute the 2 to each of the terms. And that gives us 4y minus 6 minus 4y equals 5. And what we notice here is it's a little bit different than the other two because the y's cancel. And what we're left with is negative 6 equals 5. Now we know negative 6 doesn't equal 5, so our answer to this one is no solution. Now there's 3 different types of answers to these systems. One is one solution, which we did in A and B. The other one is no solution, which is what we did in letter C. And the third option would be something like 4 equals 4 or 0 equals 0. And that would be infinite amount of solutions. And so if you get something where the two numbers are equal, that would be 2 lines that are exactly the same, or 2 equations that are exactly the same. Now, let's look at solving using elimination. Now, in order to solve using elimination, what we need are opposites, because when we add up opposites, what we get are 0, and so the letter eliminates. So in this case, we have opposites. So when we add these 2 equations up, what happens is they cancel, they become 0. So we have 6x equals 6, that means x equals 1. We're going to plug it into one of the equations. This time I like the bottom equation. Once again, it doesn't matter which equation you pick. So I'm going to plug in the 1 in for the x. 2 times 1 is 2, plus y equals 0. So that means when I subtract the 2, y is equal to negative 2. So my ordered pair is 1, negative 2. Now for the next one, what I'm going to do is either cancel the x's or the y's. In this case, I like the y's. So I'm going to multiply my top equation by 2, and I'm going to multiply my bottom equation by 3. Now when I multiply it by 2, what I get is 8x plus 6y equals 50. When I multiply my bottom equation by 3, I get 15x minus 6y equals 42. Now, if we're looking at this, notice that when we combine these two, we have opposites, and that's why this works with elimination. Because when you add opposites, one of the variables cancels, and we could actually solve for the other one. So that gives us 23x is equal to 92. Then what we're going to do is we're going to divide by 23, and that gives us x is equal to 4. So I'm going to take the 4 and plug it into one of the equations. I like the top equation this time. So 4 times 4 is 16, plus 3y equals 25. I subtract the 16, and I get 3y is equal to 9. And then when I divide by 3, I get y equals 3. So my order pair is 4 and 3. Now for our last one. In this case, what I want to do is either cancel the x's or the y's. I think I like the x's this time. How I'm going to figure out which one to use is I want opposites. So I know that 2 doesn't go into 5 and 5 doesn't go into 2, but I know that both of them have a 10 in common. So I'm going to multiply the first one by 5, and the next one I'm going to multiply by negative 2. Why I'm multiplying it by a negative instead of a positive is because I need opposites. When I multiply my top equation by 5, I get 10x minus 15y equals 65. When I multiply my second equation by negative 2, I now get negative 10x plus 16y equals negative 70. Notice that I now have opposites, and that's what I want, because when I add opposites, they cancel. So I get y is equal to negative 5. Now, once I have my negative 5, what I'm going to do is I'm going to plug it in, either the top or the bottom. I think I'm going to pick the top. Negative 3 times negative 5 gives me 15. So I have 2x plus 15 is equal to 13. I subtract the 15 and I get 2x equals negative 2. So x equals negative 1. So my ordered pair is negative 1 and negative 5.